Hello guys, this is Trockers. Welcome back. Today we are focusing on graphs and transformations. So we are given that quadratic function which can be expressed in vertex form. So part A we have to express that in vertex form. Part B we need to state the sequence of transformations, and part C we need to graph it. Right. So guys, when we are considering this problem, all you need to know is that for graphs, you need to know your transformations. You've got translation, horizontal, vertical. We have reflection, horizontal, vertical, and we have stretch or compression, horizontal, vertical as well. All right, so let's not waste much of the time here. Right, so this problem here, we are given that. So we want to express 2x squared minus 4x plus 6 in that form. So there are two ways of doing this. I'm going to do both. Right. So the other one is when you are given this identity. So you can express it right in terms of that identity, or you can just complete the square. So here, which is equal to a. So this is first term plus 2 times first and last to bx plus last term squared plus c, which is equal to ax squared plus 2abx plus ab squared plus c. Then you can compare. So when comparing, you can see that a is 2, then 2ab equal to negative 4, but this is 2. So 4b equal to negative 4. So b is negative 1. Then a, remember my a is 2 times negative 1 squared plus c should equal to 6. So c is equal to 4, right? Hence, we can express in that form with, we can express it in the form a, which is 2, then x minus 1 squared plus 4, right? Or come with, stay with me. I need to show you how to complete the square. So when completing the square, you have 2x squared minus 4x plus 6. Remember, to complete the square, guys, first this must be 1, but we cannot divide, so you take out 2, and we have x squared minus 2x plus 3. Then from here, right, it's always x squared minus 2x. Then you're going to add half of this squared, then immediately we subtract that, right? Then we consider this trinomial, a perfect square trinomial, so it's just x minus 1 squared minus 1 plus 3, it's minus 1 plus 3, it's plus 2, right? So we have 2 of x minus 1 squared plus 4. We just distributed. So we still get the same thing. A is 2, B is negative 1, and C is 4. Okay, so now that we have this, allow me to write it here. It's 2x minus 1 squared plus 4. This is part A. So moving to part B we need to state. Hence, we are using the above result. So when we have the graph of x squared, our f of x here is equal to x squared. So the first step is to say f of x minus 1. So we have x minus 1 squared. So here, that's a shift. You're going to shift 1 unit right. So this is a translation. The graph is shifting 1 unit to the right. Then you can have this. So it's 2 g of x is just this transformed function. It's 2 of x minus 1 squared. So here, that's a vertical stretch vector 2, then plus 4, right? So when I have my k of x plus 4, remember k is just this transformed function, which is 2x minus 1 squared plus 4. So it's a shift 1 unit up, right? So these are the transformation, or just a translation with a vector 0, 1. Okay, so with that being said, now we need to graph and show clearly all key points. So I always tell my kids that if you don't know, so I need this part here, right? If you don't know how to apply the transformations, you can do it this way. But let's start with the transformations first. So you know that your parent graph, right? The parent function graph for x squared passes through 0, 0. Then it shifts 1 unit to the right. So when it shifts 1 unit to the right, it's like this, right? It's 1 here. Remember, the function is now x minus 1 squared. So when x is 0, y is 1 here. We need that key point. Then we multiply by 2. So it's now this one here, which is 1 and 2 because it's a vertical stretch. Then we are going to shift 4 units up. So when shifting 4 units up, whatever was happening at 0 is now taking place at 4. Whatever was happening at 2 is now taking place at 6. So here it remains 1. So your graph will be like this. So the key points are 1, 4, and the y-intercept 6. Right. That's what we do. Or you can use the vertex method. So using the vertex method, guys, this is what we do. This is what we do. This is what we do. All right. So if the quadratic function is expressed in vertex form, you know that your vertex, okay, when you solve this part, x minus 1 equal to 0, so x is equal to 1. So your vertex here, right, your vertex is 1, 4. Then your y-intercept here, y-intercept. So remember to find the y-intercept. It was once given as 2x squared minus 4x plus 6. So always your c value is y-intercept, which is my 6. Or you can plug in 0 for x. 0 minus 1, negative 1 squared, it's 1 times 2, 2 plus 4 is 6. Then you need your zeros. Okay, we'll get there. With this one now, it doesn't have the zeros, because if you try to solve 2x minus 1 squared plus 4 equal to 0, here it does not have real roots, right? So we cannot solve this, meaning to say it does not have x-intercepts, right? So don't worry about that part. Don't worry about that part, but we can use whatever information we have. So we can either, we're going to use this or y-intercept in the vertex. So we are going to have this part and that part. So my y-intercept is 6 here. Then my vertex is 1 and 4. So vertex, guys, is the turning point. So obviously your graph will do this. And now we have sketched that. With that being said, guys, it's time for me to go. Take care. See you in the next segment.